All right, this is the second video in our group on collections, and it will discuss lists. All right, if you've read the Word doc, Python list part 2, you will see that we're going to go ahead and define a list, look at several methods associated with the list, show examples, and then at the end I'm going to assign homework related to this. So from W3 Schools, I found at least one reasonable definition. A list is a collection which is ordered and changeable. In Python, lists are written inside square brackets. Okay, so list 1 equals, and I have a group of odd numbers, 1, 3, 5, 7, 9. And then we can print that, and I'll put a space after it. So if I look at this, and with any luck, there we go. So that is basically your creation of a simple list using just writing it out. All right, the advantage to us is that there is something called append, which will put something at the end of a list. And so if I save this and then run it, you'll notice that stuck 11 at the end. So if I want to create a list, I can use a for loop. For I in range, say 6. Let's do the, well, we can just do it this way. List 1 15 times I. All right, so let's run this again. And you will notice that we get the old list, and then we add in multiples of 15. So append becomes very useful in generating new lists. That also means that if I have a function, say I wanted a list of all of the values for sine for a series of angles, well, I could write a function that would store those in a list. And that's one of the things that I find very useful about append and lists. The next item, or the next method that we want to look at is extend. And what extend will do is place an iterable item at the end of the list. It will extend it. Well, a tuple is iterable, so I can add all of this tuple onto list 1. So we ought to have 75, 13, 15, 17, we hope. So save that and roll that up so we can see it. And there we go. There's the 75, and it effectively extended or appended multiple items onto the end of the list. So that's another way you can make your list larger. Now, let's say that you don't necessarily want to always put things at the end. I can use the insert method, which has two parameters. The first parameter is where are you going to put it, and the second is what do you want to put into the list. This is going to be an index, so if we look over here, remember we have 0, 1, 2, so the number 2 ought to go where our number 3 is now, and everything should be shifted back. So let us save that and then run that. And notice 2 goes where 3 is and everything else is pushed back. So insert lets you put a new element into your list, but you can choose where you want it. It can go anywhere. This can be, this obviously is one item at a time. Well, you don't necessarily always want to add things to your list. You may want to remove something. So this will remove the first instance of the number 2 from the list. Well, this is, you should prove this to yourself by having more than a single value of 2, but it should then just remove that 2, and we should be back to the same as we were before, and we'll see what happens. Let's save that first, and then run that. There you go. So up here, down here, the same. The 2 that we inserted has been removed. So you could find an item at a particular index and then remove it. All right, we want to remove a number, and it says pop. Well, let's see what that does. So we're going to print list 1, and notice in this case the item is returned and we can store it. So it says the number removed by pop is. So again, save and run. Okay, so notice that this is an index. So I effectively removed the item at index 1, which is 3, but it got stored in a variable that I can then use. So this works off of an index, where remove works off of a value that's in the list. So I can get at items either way, either by knowing the exact number that I want to remove, or the index from which I want to remove a number. I want to know if number 9 is in my list, and if it is, what is its index? I'm going to assume that I have that number, and we're going to then print the index of the number 9 is. So that gives us a way of getting a hold of that index. And so it says that the index of 9 is 3. 0, 1, 2, 3. Works wonderfully. So now I could remove the item by using remove list1.remove and have index 9 in as my parameter. One of the things that one often wants to do with a list is to sort the list and get all of the numbers in correct order. It turns out that there are 2 methods for doing this. One is sort, and the other is sorted, and it is a method that I find much more useful. The sort simply rearranges, but you can't get back to the original list. So I've now created a new list, list 2, and I'm going to print it, and then I'm going to sort list 2 and print that. So let's see what happens. And save and run. All right, so list 2 was, strangely enough, this. Now, once I've sorted it, list 2 is the numbers in order. Okay, so the original list 2 is gone. And you say, well, why do I care? Well, it may be I need to work with the items in order for some reason, and I may want to hang on to that so I could do something else. But it is nice to know that you could have a method that will save the original list. So let's look at that next. All right, now you'll notice that list 3 is exactly the same as list 2. That was just to make my life easier. So now the sorted list 3 is going to be stored in list 4. I'm then going to print list 4 and then print the original list 3, just to illustrate that you can do that. All right, so list 4 is the sorted list, just like it was up here. But list 3 remains intact. so that if for some reason I need to get back to it, I can. So I know from the sorted version effectively what's the smallest number, what's the largest number. But if these were if this was data that was collected on specific days, I may want to be able to retrieve, I may want to be able to retrieve, say, the high temperature for the first day and the high temperature on the last day of, this data collection. Okay, that gives you a set of methods to use with lists. You can create them, and I showed you two different ways. You can simply know that these are the numbers I want in my list. Actually, I showed you a bunch of ways. I can append to the end of the list. I can use a loop to loop through, in this case, a range of values or a range of numbers, 0, 0, 1, 2, 3, 4, 5, and append 15 times I, and you get a new list. We can extend the list by adding a iterable item at the end. I chose a tuple. You could add two lists together using extend. You can insert an item at a particular index and then the value. So it's index and value. I can remove that if I went, oops, that's not what I want to do. I can remove something from a specific location. This removed a specific item. This removes something from a specific location or index, and it is stored in a variable. I can get the index of any value or any element if I know what the element is, and so I can do list.index and send that number in, and it will give me the index. And then I showed two ways to sort, one which effectively destroys the original, and one that keeps the original and returns a new list that is the sorted version of it. Okay, so if you look at the bottom of the handout, and if you look at Canvas, you will find that there is an assignment to go along with this.